we're doing lesson 1.1, functions and continuity. So it's a whole lot of weird information that you haven't really done before. So just buckle up. Learning objectives, we're going to determine continuity, domain, and range of functions. And then we're going to use those to write two different kinds of notation. One's called set builder, one's called interval notation. Okay? So the first thing said a function describes the relationship between an input and output. So in order to be considered a function, each input or x value is only allowed to have one output. So if I just say this, repeated x's is not a function. I just like saying things different ways because sometimes one resonates with you better than a different way, right? And then what I encourage you to do is as we go through these modules, they're not called chapters, they're called modules. This is module 1, 1.1. As we go through these modules, build a deck of flashcards for module 1. It'll make studying for the test much easier. Okay, so you build that deck of flashcards, and then you get to module 2, and you keep module 1 and 2 together. And you keep studying that deck of flashcards. Why? Because it makes studying for the test, studying for my final exam, as well as SAT easier. Because you get all that information from long-term or from short-term to long-term memory. Like I can, at the end of class, I'll be to say, what's an input? You'll say X value. If I ask you that a week from now, you may not be able to answer it. That's short-term memory, right? Like in the moment you can remember. Long-term memory is like you always remember it. Like you remember your mom's first name. Like that's long-term memory, right? What's the other kind of memory? Short-term, long-term, and what? Anyone know? Working memory. So back when I was a kid, they made phone numbers 7 digits because that was a comfortable number of digits that somebody could remember. Right? I still remember my phone number from when I was like 7 because it went from my working memory to my long-term memory, and now I remember forever, which is weird, right? So different kinds of memory. You want to get this information into your long-term memory because it makes studying for tests so much easier and so much less stressful. Anybody have a little anxiety around taking tests? It's okay, we can admit it. It's a safe place, right? So admit if you have it, right? And I can help you with that. I'm like a math therapist, right? I can help you get through that so it doesn't wait you out anymore. But the way you get through it is coming in for help a lot. So I can figure out what's getting in the way for you being able to produce on tests. And it's different for different kids, right? There's similarities, of course, but it's different for different kids. But I can help you with that issue. Okay. So if we do vertical line test, right? Vertical line drawn anywhere on the graph crosses only one time. So if I draw a vertical line on this graph right here, how many times did I hit the function? One time, right? I hit it right here. Okay, if I draw a vertical line on this function, how many times did I hit the function? I hit it one time right here. Okay, so that means that's a function. If I draw a graph like this, and my function looks like this, and I draw a vertical line, how many times did it hit that graph? Twice. Is that a function? No, it is not. That function would be like plus or minus the square root of x plus 2. Right? You'll know that by the end of the year, right? And that's kind of crazy, right? So if it's a plus or minus, that's what makes it not a function. This top of this is a square root function. The bottom of this is a negative square root function. Do you remember a parabola looks like a U? And if you put a negative in front of the parabola, what happens to the parabola? Upside down. Okay, it just flips it upside down. So it's called a reflection over the x-axis. You should have learned that in Algebra 1, but that was a long time ago, right? But just know you got to remember this stuff for SAT. So if you had a geometry teacher that didn't challenge you, right, and you don't remember a whole lot of geometry, I'm going to put some geometry into your Alex topics to help you remember some of that geometry, okay? Because it'll help you on SAT. So the domain is the next, oops, too big. Domain, make it bigger. What's domain, X or Y values? Here's how you remember, range is Y values. So this is how you write an ordered pair, right? X, Y. So if I think which is domain X or is range Y, or how's it work? I can also write D and R in alphabetical order. So if I think about this, domain is X and range is Y, right? Still in alphabetical order. So like if you look at that and you're like, oh, I get that, then make a flashcard. Right? Put X, Y on one side of the flashcard, put D and R on the back side of the flashcard. Okay? All that stuff will help you remember. So you want to develop, as we go through this, an organized use of color to help you take notes. Right? It can't be haphazard because then it makes you learn less. You always want to have an organized use of color, and it enhances your memory, especially if you're strong visually. Does anybody know the learning modality that is strongest for them? There's visual, auditory, and kinesthetic. Visual and auditory are self-explanatory. Kinesthetic is like doing things with my hand, like I have to do math problems to understand them. Do you guys know what it is for you? Who knows? Just out of curiosity. Not many. You can take like a stupid online test to determine that. It's worthwhile knowing. I know for me, my auditory is the weakest, which makes school really hard because teachers talk at you a ton. But I do the visual as well, plus your writing, so I employ all three learning modalities, which helps you learn better, right? But auditory is my weakest. Kinesthetic and visual are pretty much tied for me. Kinesthetic is strongest by a little bit. So if I'm doing things with my hands, I learn and I remember it the best. Okay, so knowing that about yourself helps you do better in school. So take a little test to learn that. It'll help you. Do you remember domain and range? So domain is X values. How many X values does this function include? I'm going to erase my extra lines here just so it's not confusing. Right? So I'm looking at this function here and it goes down forever. And it's angling to the left forever. And this is angling to the right forever. How many X values does it include? All of them, right? So what do we call that in math? All, anybody remember? Begins with an R. All real numbers, okay? You make the symbol for all real numbers. I call it the double stick R. It looks like this. I just make two vertical sticks and I make an R like that. It's always weird when I do it like that. I'm gonna make it better. Okay? All real numbers, that's what that means. So if you don't remember that, if you never knew that, that's another good flashcard moment, right? Write that stuff down so you know. How about the range? Where do the Y values start on this graph? What value? Range is Y. They start at 0. Are they smaller or bigger than 0? Smaller, so less than. Does it include 0 or not? Yes, it does, so it has to be equal to as well. Okay? Because if I get this ordered pair right here, it would be 0, 0. That's why it includes 0. Okay? If I look over here, so does anyone know what that graph is? Like the equation of that graph? So if you have your graphing calculator, get it out. So if I'm at the home screen right here, you can clear anything out. And if you don't have a graphing calculator, this is the point where I'll start to make you regret not having a graphing calculator every day. Order it on Prime, right? Remember, if finances are an issue for you, talk to me like after class and we can fill out a form and you can rent a calculator out. I think they make you pay for it, like $30 $10 or something, but I'm not totally sure. So right here, you're going to hit y equals. Right here, hit y equals. Yep. No, that's scientific. Yeah. Hit y equals right there. What you're going to hit is negative right here next to enter. You're going to hit x next to alpha. So negative x squared is right here, kind of diagonally up from 7. So you hit y equals right here, then negative x is next to alpha, and squared is diagonally to the left of 7. So I'm going to show you on here, negative x squared. So get that in. You can put it in technically any of these, y1, y2, y3, y4. I could put like 10 graphs on here, right? I don't need to do that, but I could. And then hit graph. Graph's in the upper right-hand corner of your calculator. And then you see the graph we just had, right? Negative x squared. Yes. Y equals is right here, upper left-hand corner. No problem. Yeah, ask those questions because it'll help you. We'll use these graphing calculators a ton in here because it'll help you on SAT. It'll help you on all the other classes.
Y equals what again?
Y equals negative. X is right here. And then squared is diagonally up left from 7. Right here. So negative right here. X next to alpha. Squared is right here. Middle left. And then hit graph. And it should look like this. Okay? Okay, you good? It's important, like first little calculator moment. It's nice. Okay, so when we look back at the notes, this function is a quartic function. What degree is quartic? How many quarters in a dollar? 4, fourth degree function. So this is like x to the fourth, but it's got more to it to make it curvy like that, make it look like a W. So it's positive quartic. What's the domain of this function on the right here? Good? All real numbers, right? Because it angles up forever, angles to the left, including all negative numbers forever. So all reals for domain. Where do the y values start on this function? -3. Is it greater or less than -3? Greater and equal to or not? Yes. Greater than or equal to -3. So every period except this one so far, kids will ask me to slow down. So if you need me to slow down, I can try to. But we got a lot to cover today, so I need to go kind of fast. Again, we'll have the video posted on the Schoology page, and you can get the video and listen to like an example or two if they got weird for you. Okay? So example 2 here says, sketch a graph of a function with the given domain and range. Domain is all real numbers. Range is y is less than 2. I'm going to freeze the screen up here. You try it on your paper. Definitely in pencil in case you do it wrong. Try it on your paper. Talk in your table groups. That's why you're in these groups, to help one another. So talk in the table groups if you need to, and try it out. Yep.
How would you write the y equals
You can't in the calculator. There are ways you can kind of limit the part of a function it'll show, but we don't need to do that this year. But we'll show you how to figure out what this graph is so you can put it in your calculator. Okay? All good questions. Talk to one another. It's good. You can help each other. Okay? Raise your hand if you're ready. If you already did a graph, just take a guess. Who cares, right? So take a risk. It's all going to be okay. That's what it should look like. Okay? How many people had a graph that looked something like that? Okay, good, good. There was a lot of hands up. So what is the equation of this graph? If I make it upside down, it's y equals -x squared. How do we make it go up 2? Started at 0 and it went up 2 right here. Plus 2. So if you have a graphing calculator, plug that in and you should get the same graph in your graphing calculator. y equals, go to y equals upper left-hand corner, hit negative x squared plus 2. Question?
Is this giving me error syntax?
What did you do? Did you hit a minus instead of a negative?
Oh,
So negative's next to enter.
wait. Yeah.
Because if you do minus, like plus minus divide, that minus, it doesn't get it. So negative's right here, right? Next to enter. Okay, so you can see the graph looks like that. It just took that upside down parabola and moved it up too. So we'll learn how to move that up, down, left, right, make it skinnier and make it wider as well, okay, during the course of the year. You'll learn more graphs than you ever wanted to know this year. You'll love it, just love it. Okay, so discrete versus continuous, next page. So we're going to learn the difference of those two words. You need to answer A and B for yourself. I'm going to put answers relevant to me and my family, and me and my commute to work, your commute to school. So I have 4 children in my family, and it took me 11 minutes riding my bike to get to school. Okay? You do that for yourself. Whatever it is, however many kids are in your family and however long it took you to get to school. You live in Erie, it takes you like a half hour with traffic, right? You live in Rock Creek, it takes you 5 minutes. Depending when you get here, right? You live in Frederick, it takes you like 45 minutes to get here. It sucks. Who thinks they live the furthest away? You may not want to say where you live though, so we won't say that. Okay, you have answers for your A and B, whatever they are for you. It doesn't matter. There's no right or wrong answer, right? It's relevant to you. And then next it says, is 5.716 a possible answer for A? That's kind of messed up, right? Can you have 0.7 of a kid? Do you chop the arm off? That's messed up. Don't do that, right? Could we round this up? That means I chopped the arm off and then I stuck a stick in the hole. No, we're not doing that either, right? That's messed up too. So for me in my class, if we're talking about living things like animals or people, I say you always round down. Even if it's 5.9 is your answer should be 5. Because I'll write on your test, what'd you make the 0.1 of the animal out of, you messed up person? Right? That's messed up. You don't do that. Right? Stick, mud, clay. No, you don't make a foot out of clay and stick it on an animal. That's messed up. Okay, so always round down for animals. Now, SAT might be different. So you just got to know, because we don't have time to go over SAT. I said that at back to school night last night. Some parents got mad. And I'm like, that's the way it is. Sorry, I don't have time. I got to teach you. Okay, next one is, so discrete functions model real. Discrete's the first little blank space right here. Model real world situations where only some numbers are possible. Okay? So if you're buying apples at a store, you can't buy a quarter of an apple. Right? You have to buy apples whole. But if you're buying apples, that's discrete. If you're paying for apples, that's continuous. Because you buy 4 apples, they might weigh 4.2 pounds, and they charge you per pound, so that's continuous. Anybody drive? You fill up your car with gas, right? That's continuous. Because you never fill your tank has 24 gallons and you fill exactly 24 gallons every time, no. Right? Because you always have some gas in your car. Anybody run out of gas in your car? I have too, twice. It's when you're really not that smart, right? Or just one time. I'm older, so yeah. It's rough. It's not fun running out of gas. Then you're pushing your car to the gas station, and you're like, oh my God, I feel so bad. Okay, next one is real world situations where all numbers are possible are continuous. That is not how you spell continuous. Some letters there. Oops. continuous functions. So we have all three. We're choosing between continuous, discrete, or neither. This first one is continuous because there are no breaks, right? It's a smooth graph. There are no separations anywhere. That's what makes it continuous. This graph, the middle graph, it's continuous for this portion, and then we have this hole right here, and then it's continuous for that. So it's part continuous and then a hole. That makes it neither. What do you think the last one is? Of course, right? Because that was the third one. So when it's random dots spread around, it's got to be discrete. If we look at this first graph here, what's the domain of this first graph? Like, because this angles out ever so slowly, will it include all positive x values? Yes or no? Yes, it will. Will it include all negative x values going down like that? So what is it? All reals. How about y? Range. Because these arrows on y keep going up forever, and they keep going down forever, right? So will it include all y values as well? Sure will. So that's a cubic function. When it's got a wiggle in the middle like that, that's a cubic function. So that is also all reals. Any cubic function will always have all reals on both domain and range. We can hardly ever say that in math where it works that way every single time, but for cubic function, it works that way every single time. It's always all reals for both domain and range. So if we talk about domain here, it's all real numbers except what x value? Two. Good. Right? So it goes every single, because it goes forever that way, forever up top, but it skips 2 right there. Right? So it skips the 2 right there. And then what y value does it exclude? 1. So all reals except 1. Do you have to put x or y for range? Y. Good. Just testing you. So not equal to 1. The next one's kind of a pain in the neck, right? So what's the smallest x value right here? Negative what? Count. -3, then -2, because this point is -2, this point's -1, and then 1, 3, and 4 as you go along. When you list domain and range, you must list at least the greatest, no repeats. So we start at -3, then -2, then -1, then 1, and then 3 and 4. So list domain and range, least to greatest, no repeats. It's a good thing to write down. If you forgot from freshman year, it was a long time ago. Least to greatest, no repeats. Then range values, we start with the smallest, right? Because it's least to greatest. So the smallest y value is what? -3, -2, 1, 2, 3, 4. So -3, -2, 1, 2, 3, 4. And you can just go from the dot over to the y-axis. That's how you know. So we have -3, -2, 1, 2, 3, 4. So next we have this super weird, funky notation you're just going to have to get used to, okay? I'm going to make some graphs on the left there that I made in my notes. So when I created these notes, I just made up the numbers there, so don't think it's any weird magic thing. I just made them up. So this one, we're going to go 0, 1, 2. We're going to have an open dot, and the arrow goes to the left. Okay, and then next one, we're going to start at -3. 0 would be there. We're going to have a closed dot. Arrow's going to go to the right. Middle one, we're going to have 0, arrow goes to the right, close stop at -1, and arrow goes to the left. I'll make those bigger so they're easier to see. So just copy down what I did. No magic to it, just copy down. It's not 0, 0. I like making my graph above the number line because I get kids that'll do like, they'll make it like that and they'll say, can't you tell? It's an open dot. And I'm like, if I have any doubt, I just mark it wrong. Right? So just make your graph, if it's a number line above the line, just easier. I know why it does look like 0, 0. Just an open dot above 0 is what that is. Okay? Set builder notation. Here's the weird part. You always start with a bracket. So it looks like one of these guys, right? And it's always, this means X such that X. That's the beginning of every single one. It's just notation you have to get used to. It's, first time I learned that, it made me mad. I'm like, that's stupid. Why should I write X such that X is greater or less than something? It's just the notation. Don't shoot the messenger. So you can start all of them like that. X such that X, and then we'll finish it off with the number part. You can also do a closing bracket. We're going to write a greater than or less than sign, a number, and you can close it after. So I'm going to close it as well. It's just easier to do it that way. My brain goes crazy when I make a bunch of them in a row, so they look worse and worse, but good enough. So get that down. Just making brackets on the ends, an X with a vertical line and another X. That's all. So if I look at the very first graph here, is it less or greater than 2? Less, is it equal to or not? How do you know if it's equal to or not? Dots filled in, it's equal to. If it's an open dot, it's just greater or less than, depending. Okay? So the first one is less than 2. What's the second one? This one right here. Greater than or equal to -3. Perfect. Greater than or equal to -3. How about the middle one, or the third one? Greater than 0. Last one, less than or equal to -1. Okay? That's set builder notation. You always have brackets at the end. You have X such that X, and then greater or less than a number. Okay? Interval notation is different. I find it easier. If I'm giving you a choice on a test, I'll make you show me both, but usually I'll do interval notation because I find it easier. Right? It's less annoying. I hate drawing these little symbols because my brain goes crazy. It doesn't really work in my noggin. Okay? So interval notation always starts with negative infinity or a number. It always ends with a number or positive infinity. So we always go left to right on the graph. So if I look at this number line graph, the first one, it starts at negative infinity and it goes to positive 2. So negative infinity to positive 2. When I draw an infinity symbol, if you're challenged, like I was super challenged doing that for a long time, I start in the middle and I go down, around, and back. Then my brain, it works for my brain. It's weird. It messes with my head. Where does the next graph start? The second one. This graph right here starts at -3. Okay? So because it's a closed dot, your bracket is squared off, not curved. It's always curved at negative or positive infinity. If it's an open dot, it's a curved bracket. If it's equal to, it's squared off bracket. Okay? So it starts at -3 and goes to what? Positive infinity. Always curved at infinity. The next one starts where? The third graph down starts at 0. Is it curved or squared off? Curved. Open dot, curved. So it starts at 0 and goes to positive infinity. Always curved at infinity. The last one starts at negative infinity and goes to -1, and is the last bracket squared off or curved? Squared off. Okay? Go ahead. Closed dot, squared off bracket, open dot, curved bracket. Okay? That's why it's so nice, this ability to be able to like do that on the iPad, right? Because you go back and listen to that video and you know exactly what I'm talking about because it'll tell you. Yep. So this one's squared off because the dot is closed, right? This one is curved at 2 because it's an open dot at 2.
No, but I was talking about like the second one. It's a square off.
It's always curved at infinity
Oh.
every single time. Negative or positive doesn't matter. And you always go left to right. That's the key. All right, last page. So we have these weird other symbols. We already know about infinity. We have this one means element of. It's like an E with a curve. It's like a C with a line in the middle. We know all real numbers. This means intersection or union, okay? So we'll talk about them with these two graphs right here. So we're going to write both set builder and interval notation. So if we write this first one with all real numbers, that's the domain, right? You write it like this with the set builder notation. So you write your little bracket thing, x such that x. Then you write this means an element of the curved E thing, like that with a line in the middle. All real numbers. You write the double stick R now. And then you do a closing bracket. Like this kind of stuff always made me mad at math because I'm like, why? Who cares? Like, why did we do it that way? See that little curved D thing? It's funky. Interval notation. We're still on domain. Set builder means that we've got these bracket things on the ends, right? And it's always x such that x is something. Interval notation is like up here. These ones are interval. These ones are set builder. Okay? It's a good question, right? Because it gets confusing. There's so many different, you're like, why do we have to write both? You just do. All right, interval notation. What is the domain? It's all real numbers, right? So interval notation, it goes from negative infinity to positive infinity. That's all. Right? That means all real numbers. Now the range. Set builder notation. So you have the little bracket thing, and it's y for range, right? So don't forget to write y. Y such that y is, where do the y values start? -6. Is it greater than or less than? Greater than, and is it equal to or not? Yes, it is equal to. So greater than or equal to -6. Then closing bracket. Interval notation. At -6, is it squared off or curved? Squared off. So it starts at -6 and it goes to positive infinity. Good. Okay, that is it. Your homework, you can write it on your notes if you want. Oh, I didn't do this one. We need to do it, sorry. I'm going to write it. So domain is x such that x is less than -1, because it's an open dot at -1, or x is greater than 0, greater than or equal to 0. Interval notation, it goes from -infinity to -1. And then union means that it also includes, that big U thing, means it also includes, it starts at 0 because it's squared off because it includes 0, and it goes to infinity. Always curved at infinity. Range, similar concept. Y such that y is either less than -1 or greater than 2. Greater than or equal to -2, or +2, I mean. Or y is greater than or equal to +2, close your bracket. Interval notation goes from -infinity to -1. Got the union symbol, and then from 2 to infinity. So way to hang in there on that lesson. It couldn't be more dry and boring, that lesson. I fully acknowledge that, understand it. The interval and set builder notation might annoy you, but you have to use it. So just get used to it. I'll ask you for both on a test, but I'll always go towards the interval notation because I find it easier. I'll write the homework up here for you. So homework is page 9. You're going to do 1, 2, and 3, domain and range only. So I'm just going to write D and R for domain and range. And then 10, 11, 16, 17, 19, and 20. That homework is always, you can click on the Module 1 folder, and the assignment calendar is inside of that Module 1 folder, okay?